All right, so today what we're going to do is we're going to look at the second method for finding the equation of a parabola, right? So we were going to look at both of them last time, but we got through the first one and then stopped. So we're going to do the second one today, right? So remember last time we looked at what happened when you knew the x-intercepts. Do you remember that? If you knew the x-intercepts, find those x values. They go right into the brackets, right? Then choose any other point on the line and use it in place of x and y and solve to find out if there's an a value or not. And if the parabola looks very wide, your a value is going to be what?
A half or a fraction.
Some fraction or a decimal, good. If it looks very narrow, it's going to be a whole number. And if it looks just kind of normal, then your a is 1. Mm-hmm.
It's like 3.5.
Well, it's bigger than 1, so it'll be narrow, be very narrow. Yeah. So something less than 1 is going to make it wide. Okay? All right. So today what we're going to do is look at method 2. And method 2 uses that vertex form that we looked at when we first started graphing a parabola. So do you remember the vertex form is y equals a times x plus or minus b quantity squared plus c, some constant. Do you remember that? Because remember we were using the b and the c to find the vertex, and then we were able to find some other point and use that to plot the parabola. So what we're going to do today is we're going to look at using the vertex form to graph these. Now again, you could always use, this one is generally used when the x-intercept values are difficult to read or non-existent. Not every parabola is going to cross the x-axis. It could be opening up and be above the x-axis. It can be opening down and be below the x-axis. So if that's the case, then we can try the vertex form. Also, sometimes it's just difficult to read the x-intercepts because they may be between the lines, right? Not on easy to read points. And so the best you could do is estimate them. But we can usually find the vertex. And as a matter of fact, there is an algebraic formula for that you would use, but they just don't use it in this course. All right. So y equals a times x plus or minus b squared plus or minus c, right? It can be a negative or a positive. Okay? Now, if you're going to use something called the vertex form, we would probably use this when we what? Know the vertex. There you go. All right? So it's used when you know the vertex. Okay? Because that will tell you, the vertex tells you your B and your C. Remember that your C is your vertical shift, up or down from the x-axis, and your B is your horizontal shift, from either right or left from the y-axis. Do you remember that? Okay. Well, if you know those 2 points, then you know if you know where the vertex of the parabola is, then you know what A and what B and C are going to be. The only thing that you remember is that when you replace the b, if you take a number away from an x, or if you put it back into a bracket with an x, what does that do to it? Change the signs. Good. Okay. So here are the steps. Yeah. First, find the x and y values of the vertex. Definite asylum for me. Probably sooner than later. All right. Now, the x value becomes the b. But again, remember, because you're putting it in a bracket, you need to change the sign. It's just under it. You can put it as another step. I don't care. Step B. Okay. Step C. The y value becomes C. And again, but this time, remember, you're not going to change the sign. So the y value just becomes your c. Again, you have to have it in the right format. Okay. D. Choose any other point. So this is where it becomes just like the other one. Choose any other point and substitute that to find A. So you're just going to plug in those values for x and y and then solve the equation to find out what your A is. Again, remembering, you can kind of have it see if there's an A. If you think it looks normal, then your A is probably 1, but you still have to do this. And now you're going to see that most of the time, they recommend that you use a specific point, and we talked about this with the other one, the y-intercept, right? And the reason for that is that it makes x turn into a 0, which makes it easier to work with, right? So, all right. Everybody get it down? Good? All right, so let's just go to the book and look at a couple of these. You're going to find these are pretty much just plug and play. You're just going to find the vertex, x and y values of the vertex, stick it in, then solve for some other point to get your A. So this is on page 48 of your book is where they start with their ones. Let's just look at some from the homework. Okay, so here look at number 4. Just for kicks. All right? So, for number 4, this one does cross the x-axis, yes? Okay, so if you look at this one, this parabola does cross the x-axis, yes? But if you look at where it crosses the x-axis, let me use a better color. You see that it's in spots where it's not easy to read. We could do an estimate, but we don't want an estimate. We want the actual values for this equation. So instead, we'll see if we can find the values of the vertex. And if you look at the vertex, the turning point, that's a nice, easy point to read. Yeah? So in this one, we're going to use that vertex form. So remember, it's y equals A times x plus or minus b plus or minus c. So finding the values of the vertex, we go... Oh, sorry, thank you very much, squared. So finding the values of the vertex, if you go to the right 2 and then down 6. So the value is 2, comma, negative 6. And so those two values, this one becomes my b, and this one becomes my c. Because you just find them straight from the vertex. So that gives me y equals a times x. Now it's a positive 2, so when I bring it up here and put it in place of my b, what's it going to become? Negative 2 squared. And it's a negative 6, so minus 6. Okay? Now, so we have our our b and our c here, but what we still have to do is find our a to see if there's any multiplier in front. This one doesn't look like there might be, but there could be. You never know. And so if you look, we can easily see the y-intercept. We can see that value. It's at the point 0, negative 4. If you couldn't read that value, then just find any other value that you could find, but that one makes it nice because that means x is going to be 0. So y equals a times 0 minus 2, quantity squared, minus 6, which you don't need the 0. And anytime you're using the x-intercepts, you could just make that x go away and just put the number in there. Mm-hmm.
You don't have to do anything with the negative 4, but if we're going to use 0.
Oh, I'm sorry. Yes, I need to put that in place of y, don't I? Thank you for that. Okay. So replace your x and your y with the values from the y-intercept. Now, negative 2 squared is 4. So that gives me negative 4 equals...
Square?
Right? Yes. Square. So, guys, come on. Now be careful here. We've got a times our 4 and then minus 6. So that's going to give us 4a minus 6. Right? Then, we need to add the 6 to both sides to get the term on its own. So it is a little wider then, because it's going to give us a of 1/2. Okay. All right. So all I need to do is replace this a back up there with 1/2, which gives me the completed equation of y equals 1/2 times x minus 2, quantity squared, minus 6.
Why is it
Minus 2 because it was a positive 2, and I put it back in the bracket with my x term, I'm sorry. So anytime you take it out away from the x or put it back with an x, that automatically changes the sign. And the c was my y term, and it was already negative.
Is this just a curvy version of point slope form?
Really? No. It's the completing the square version of a quadratic. Okay? All right. So mostly you're just going to find the points and plug them in. And then there's one thing and then you're going to have to solve it. Be careful when you're solving the equation to make sure you're solving the equation right. Can't tell you how many times I've seen people do 4 minus 6 is negative 2 times a. That's not right. It won't work. So make sure. Multiplication before you do the subtraction. Right? Okay, you want to look at another one? Okay. So on this one, it looks like you could identify the x-intercepts, but don't make sure you look at it closely enough and you realize that you're not quite on the points there. So we can't really identify them, but we can identify the vertex or turning point. Okay. And if you're having trouble finding out which line, remember it's halfway between those two. So you can get an estimate of which line it's going to be on, right? Always remember that it's halfway between those two x-intercepts. All right, so we've got our point, and let's see, it looks like we went -3 and up 5. So the vertex is -3, 5.
Wait, how? Because if you look at the graph.
Yeah, if we have to go left 3
Sorry.
and then up 5. There you go. Yeah, to get to the vertex. So we get y equals a, x, and our x is -3, so I'm going to change the sign. So when I put it in there, it's going to be what? +3, good. Quantity squared, and then plus 5. Remember the c on the outside of the bracket is just whatever number you get. Now, got my a and my b and my c, but I need to find my a. By choosing any point, we like to use the y-intercept if we can, and we can in this case, because it's the point 0, 2. And they're pretty nice to you on most of these. I don't think there's any of these that you can't use that y-intercept. Okay? All right. So let's plug those in. Y is 2. A. X is going to become 0, so who cares? So I end up with just 3 squared plus 5.
Yes.
2
equals 3 squared is 9. And 9 times a is 9a.
plus 5.
Plus 5. Good.
9a equals 5 minus 2.
Well, other way around.
2 minus 5.
2 minus 5, there you go. Which gives us -3 equals 9a. Divide both sides by 9.
So you have 3.
Negative
Divide both by 3.
1/3.
Makes no sense.
Okay. Well, it doesn't matter. You can clearly do it. You can clearly do it. So don't worry if it doesn't make any sense. All right, as long as you can do it. So y equals -1/3. Knew it was going to be negative. Why?
Because it's frowning face.
Yeah, because it's going down, right? So it's upside down, right? It's frowning, and it looks a little wider than your standard one, so it should have been a fraction. And we get x plus 3, quantity squared, plus 5.
This is. Well, this is so.
What the hell is that?
I know that the weather is way more interesting than algebra, but tough.
Is this algebra?
Okay, so here we go. Of course this is algebra. Yes.
This isn't MCAT, is it?
No, not MCAT, no. All right, so what we're going to do is I'm going to give you some of these to work on so that you can find some of these. So let's see, it started on page, what was that? 49. So 49 and ends on page 50. So page 49 and 50.
Why are we not doing questions 1 and 2?
You can do them. They're scaffolded, but you don't have to if you don't want it. If you don't want the scaffolded ones. The good things about 1 and 2, though, guys, remember, is because they can give you pieces of information. And then you have to fill in the rest. And so if you're used to seeing all the pieces that they give you broken down like this, then when they give you, so say, for example, they say, mark the integral points, all right? You'll know what they mean by that. Do you see what I'm saying? So these are good for really driving home what each piece is. So even though they're really scaffolded for you and it makes the math easier, what they're really trying to do is get you to see the terminology and what pieces you're using where. So I would do them. And when you see the test, you'll see why. Okay? You've seen these NCAA tests already, and you've seen that other than the number one, you see that they're really worded funny. They like to use definitions. Okay?
Why do they